Okay, so today's lesson is mainly about figuring out what sides of a triangle or shape are corresponding to one another, and then setting up a proportion to solve for a missing side. So the key up here is matching up the corresponding sides. And you absolutely should use your patty paper. At the very least, you should redraw the shapes, and you'll see how I do it. And if you do it my way, it should work out pretty well. So these two triangles right here, it's like a bow tie situation. If you look at the similarity statement, A maps onto E. Well, if A maps onto E, then it's not a reflection. It wouldn't be reflected because A would go over toward D. So that has to be a rotation. So I'm going to take this one and bring it over here. And if you redraw this one, C, D, E, and you can do this with patty paper, 3, 2, and X, and have it sit the same way. So if you put them next to each other, sitting in the same position, you can easily see that 5 goes with 2. And if you match up a number with a number, so you can say 5 is to 2. In every one of these, you'll have a corresponding set that both have numbers, and that's what you want to use right away, the 5 and the 2. And then to solve for y, I could do y and 3, because they're corresponding. They're in the same position. So y and 3. I could also make a completely separate equation to solve for x. I can reuse the 5 and the 2, because I already know that. And then I could say 8 and x, because they're both on the bottom. And you can solve those separately to find x and y. So here I have 2y equals 15. Divide by 2, and y is 7.5. And here I have 5x equals 16. And x would be, you could leave it as 16/5. Number 2. Again, make sure you're pausing this, because I'm probably going at a speed that you're not going, so pause between, replay what I'm saying, etc., etc. So in this case, there's no similarity statement, but instead they give you these angle markings, like a little Cheerio there and a little star there and there. So if the little Cheerio maps onto the other one, then this was a reflection. It wasn't that this went down to this corner. This was a reflection. This went straight across. So the 5 is going to go with the 4, and the y is going to go with the 3. It's easier to see when it's a reflection. Another equation, I can reuse the 5 and the 4, because those are both numbers, and then I can say 6.25 matches up with x. And I can solve both of those equations. 4y equals 15. Divide both sides by 4. And you could leave it as 15/4, or you could say 4 goes into 15 3 times with 3/4 left over, so 3.75. And to solve for x, I have 5x equals whatever 4 times 6.25 is, and that happens to be 25. Use your calculators, divide by 5, and you have x equals 5. So the difference between this problem and this problem is that once you straightened them out, this was a rotation, and this was just a reflection. And then there's another case here. You have number 3 where there's a triangle hidden in the other triangle. So what I did here was I already pre-drew this one. This came from right here. So I used my patty paper, or you could just redraw it too. Take this little triangle and draw it separately over here. So ABC has the sides 1, 2, and y. And then, make sure you're pausing this if you need time to do that. And then you have the big triangle that's going to have the sides of, you have 2 and x there, you have 1 and 3 there, and you have 6 on the bottom. So when I redraw this one over here in the same position as the other one, this side is 2 plus x, and that's all you can do. You just write 2 plus x. You don't write 2x. This isn't 2x, it's 2 and x. So it's 2 plus x. This side was 1 plus 3, so that side is 4, because you can add 1 and 3, and the other side was already just a full 6. So which side in this triangle has a number that corresponds with a number over here? And to me that looks like it has to be this side and this side. They're the only corresponding sides that are both numbers. So 1 is to 4 is going to be my go-to fraction to start with. And if I want to solve for y first, I would go, I started with 1, so I'll start with y, and 6. Now my other equation would be, I'm going to use the 1 and the 4 again, because those are the numbers. And then I'm going to use 2 and 2 plus x. And I'm going to cross multiply and get 4y equals 6. Divide by 4, and that's going to reduce to 3 over 2, or 1.5. And then this side here is going to be 1 times 2 plus x equals 8. When you distribute the 1, you're not really changing anything. 2 plus x equals 8. When you subtract the 2 over, you get x equals 6. So the key in all three of these, they're all different, but to redraw the triangles so they sit next to each other, sort of facing the same way, so you can see what matches up with what. Then you find the ones that are both numbers and start your fraction off with that. Let's try number 4 now. This, let me move this out of the way for a minute and just look at the picture here. Was this a reflection or a rotation, and how can you tell? Well, this little star that was down here is now over here. So it was not reflected. It had to be rotated. So because this is a rotation, I'm going to take this one, redraw it over here like this, and then if I wanted to, I could redraw the other one, and you could do this with patty paper. Or you could just redraw them on your own. Make sure you have your letters where they belong and mark your numbers. And I'm going to move this right next to the other one so it's kind of sitting in the same position. I'll put it right here. So here you can see the bottom of each one had a number. So I'm going to use 16 and 24. Now I'll solve for y first. I'll go y, and that corresponds with 18. It's kind of like on the top left. That's why redrawing them next to each other makes it so much easier. So y over 18. That'll solve me for y. And then I can use the 16 over 24 again. And this time I'll solve for x. So I'll go the top right 10, top right x. Now 16 and 24 are big numbers, and you can use them. You're just going to have bigger numbers with your calculator. You could also reduce 16 24ths if you wanted to, which is 2/3, and it makes the fraction smaller. But that's up to you. You can certainly do it like this. And then you're going to solve 24y equals whatever 18 times 16 is. Hopefully you're listening and not just watching. 18 times 16 is 288. When you divide that by 24, you get y equals 12. So y equals 12. And over here, I have 16x equals 240. Multiplying by 10 is pretty easy. And when you divide 240 by 16, you get x equals 15. So again, redrawing them next to each other is the key to the whole thing. Now number 5, I already have the hint drawn in there, but the reason this appears to be a reflection is because you have the little angle Cheerio up here, which means it matches up with this one. If that was a rotation of something, it wouldn't be directly across from it. And this little asterisk at that angle wouldn't be directly across from that. So this was just flipped right over. Obviously dilated too, but we're looking to see if it was rotated or reflected, because that's how you set up the correspondence. So these I don't even really draw again because your eyes can see these better. Which sides that correspond both have numbers? If I look on the inner sides, the 20 and the y don't both have numbers. The outer sides, x and 15, they both don't have numbers, but the two bottoms do. So it's going to be 15 over 12, and then I can pick something that corresponds. So I'll go the outers. If I did 15, 12, I'm going to go x 15. It's a different 15, but same number. In the other equation, I'm going to use the 15 over 12 again, because I can reuse that. I'm going to do the inners, 20 and y. Then we'll cross multiply. 12x equals 225. When you divide both sides by 12, you get x equals 18.75. On this one, 15y equals 240. And when you divide both sides by 15, you get y equals 16. Now here's this number 6 again, where there's a triangle that's similar hidden inside the other triangle. So I already pre-drew these to save some time, but I'm going to move the inner one out here. And just to make it easier to see, I'm going to move the outer one. But first let me put the sides in. This entire side isn't 10x, it's 10 plus x. 10 and x together. So this side would be 8 and 2 together, which is easier just to say 10, and the bottom is 15. So when we redraw this triangle over here to make it look just like the other one, we have things that match up. It's just so much easier to see this way than looking at it like that. So which corresponding sides both have numbers? Looks like I guess you'd call it the top, AT and AE, 10 and 8, or 8 and 10 I should say. So 8 is to 10, and I can choose this one. I'll go that 10 and that 10 plus x. 10, 10 plus x. There's a lot of 10s here, but they all mean something different. The other equation, we have the 8 over 10 again. And I have y over 15. And then when I distribute, after cross multiplying, I have 80 plus 8x equals 100. I'm going to subtract 80 from both sides, get 8x equals 20, divide both sides by 8, and I get 8 equals, or x equals 2.5 right here. This direction, I have 10y equals 15 times 8. So that's 10y equals 120. Divide both sides by 10. And y is 12. So your assignment, number 42, will just be page 14. And I have a couple of hints here. A is a reflection because of the way the little Cheerio angle maps right on straight across. B is actually a reflection as well, but one's pointing the other way. So if I put it right here, it would look like a reflection right down the middle. So that's kind of what you want to do there. On C, it's a reflection again. Good luck in quiz tomorrow.